Let us solve this exercise now. This is miscellaneous exercise of permutations and combination. So how many words with or without meaning, each of two vowels and three consonants, can be formed from the letters of the word daughter? We have done such a question in the examples also. So let me count the number of vowels first. A, U, E. So I've got three vowels and 1, 2, 3, 4, 5 consonants. And let me see if all are different. D, A, U, G, H, T, E, R. So yes, all are different. So three vowels, 5 consonants I have got to choose from, and I need words with or without meaning, each of two vowels and three consonants. So each word should have two vowels and exactly two vowels and three consonants. So I have to choose two vowels out of these three in 3C two ways, three consonants out of these five in 5C three ways. Now once I have done this much, I have chosen five letters. I have chosen five letters in out of which two are vowels and three are consonants. Now to form the words, these five letters can be arranged in 5 factorial ways. So this is my answer. 3C2 means 3, 5C3 means 5 into 4 by 2, that is 10, 5 factorial means 120. So this is 1200 into 3, that is 3600. So these many words can be formed with or without meaning, each word having two vowels and three consonants. And we have used the letters of the words daughter. How many words with or without meaning can be formed by using all the letters of the word equation at a time so that the vowels and consonants occur together? So let me tie the vowels together. What are the vowels? E, U, A, I, O. So I have got all the five vowels in this word. And then consonants are Q, T and N. Q, T and N. So there should be 5 letters. There should be 8 letters in total, right? 1, 2, 3, 4, 5, 6, 7, 8. So yes, it is confirmed that I have got 5 vowels and 3 consonants. These I have tied together, and these I have tied together because these have to stay together. These should occur together. So now I have got basically 2 units which can be arranged in 2 factorial ways, right? These I will treat this as one unit, this as one unit. So these can be arranged in 2 factorial ways. Now the internal arrangement of these vowels can be in 5 factorial ways, and these consonants can arrange or can arrange themselves among themselves in 3 factorial ways. So I'll multiply it with 3 factorial. So this is going to be the total number of words that can be formed using all the letters of the word, or given all these conditions that are given in the question. So what is this number? This is 2, this is 120, this is 6. So this is 12 into 12, 144. So 1440. So these many words can be formed. So let us proceed to this one now. A committee of 7 members has to be formed from 9 boys and 4 girls. In how many ways can this be done when the committee consists of exactly 3 girls? So the first case, I'll try to convert exactly into no, this is exactly 3 girls. So I need, whenever I have got at least or at most, I try to convert it into exactly. But now the committee consisting of exactly 3 girls can be formed by taking 3 girls and 4 boys. So this is the first part here where I need exactly 3 girls. So in how many ways can I choose this committee? So out of these 4 girls, I have to take 3 girls, that is in 4C 3 ways, and out of these 9 boys, I have to select 4 boys, so 9C 4 ways. What is this number? This is 4. 9C4 is 9 into 8 into 7 into 6 divided by 4 into 3 into 2 into 1. So this will be cancelled. This can be cancelled here. So this will be 14 into 9, that is 126, right? So 4 into 126, and this is 405. So 504 ways it can be done. So the first part, answer to the first part is 504. So this is 504. Let us look at this one. At least 3 girls. Now I'll convert it into exactly. So the second part, when I've got at least 3 girls, so the committee can be chosen like this. 3 girls, exactly 3 girls. Then I have to take 4 boys. Or this was one way of choosing the committee. Or if this was at least 3 girls, so I can choose more number of girls. So if I choose 4 girls, then I have to choose 3 boys. Only these two cases are possible because I've got only 4 girls to choose from. So I've taken all the girls in this committee. So these are the two ways. Let us see this first. 3 girls and 4 boys. 3 girls can be chosen in 4C 3 ways and 4 boys in 9C 4 ways, or so I'll have plus here, 4 girls in 4C 4 ways and 3 boys in 9C 3 ways. So this will give me, this is 1, this I think we have already calculated, 3 boys and 4 girls. This was 504 in number, so I don't have to calculate it once again. So I'll write 504 here, plus this is 1, and 9C3 is 9 into 8 into 7 by 3 into 2 into 1. So this will be 3, this will be 4, 12 into 7, 84. So 84 plus 504 will give me 885. So in 588 ways, I can choose a committee consisting of at least 3 girls. So 588. Okay, so 2 parts are done. At most 3 girls. So to convert it into exactly, how can we do it? Either I can choose 3 girls, or 2 girls, or 1 girl, or 0 number of girls. So these 4 cases are possible. If I choose 3 girls, then I have to take 4 boys, right? Or 2 girls, 5 boys, or 1 girl, 6 boys, or 0 girls, that is all 7 boys. 0 girls means all 7 boys. That means the committee will consist of only the boys. So this case we have calculated, this gives me 504. 2 girls, 5 boys will be 4C2 into 9C5 plus 1 girl, 6 boys. So 4C1 into 9C6 plus 7 boys, 9C7, right? This is 504 plus this is 4 into 3 by 2 into 1, so 6 into 9C5. 9C5 is 9 into 8 into 7 into 6 divided by 4 into 3 into 2 into 1 plus this is 4, this is 9 into 8 into 7 by 3 into 2 into 1, because 9C6 or 9C3 both are same. 9C7 and 9C2 both are same, so I can write it as 9 into 8 by 2 into 1. So this is the calculation left that you have to do. 504, 3 into 2 can be cancelled here, this will give you 2 here. So 14 into 9, 126 into 6, 6 into 126 here. plus this 2 will go here and 3. 6 into 8, 48 into 7. So I'll write it as 48 into 7 here. Then plus this will give you 4, that is 36 here. Okay, now I just have to add these. So let me see. Let me change the color. So what is this number? This is 6, 5, 756, right? 504 and 756 plus 5, 336 plus 36. 756 plus 4 is 760 and 500 is 1260 and 300 1560 and then 72. So 1560 plus 72 will be your answer. 2, 3, 6, 1. Right? Is there anything left? I believe nothing is left. So this is your answer for the third case, 1632. So these three are your answers for the first part, second part and third part. Okay. Let us move to the next question. If the different permutations of all the letters of the word examination are listed as in a dictionary, how many words are there in this list before the first word starting with E? So before E, the words can start with A, B, C or D, right? So in this word examination, out of A, B, C and D, I've got A, that's it. I haven't got B, C or D. So I just have to find the number of words starting with A using all the letters of the word examination. So let me count these first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 letters in total, out of which I have got 1, 2 A's, and what about, is there any other repetition? E is not being repeated anywhere. X is only once. A I have already considered. M is only present once. I, 1, 2. I is present 2 times. So 2 I's are there. And N is present here. N is present here. So 2 N's are there. And what else? A I have already taken. T is present only once. O is present only once. So this is the composition. That I've got 11 letters in total, out of which 2 are A's, 2 are I's and 2 are N's. Now if I start a word with A, so I've fixed this here and I've got these 10 positions to fill now. Right? So these 10 positions or 10 places can be filled in 10 factorial ways, and I have to divide it by 2 factorial and 2 factorial because of these 2 I's and 2 N's. Because of these 2 A's, I don't have to divide it with 2 factorial because I have fixed this first place. So one of the A's is gone, right? Out of the remaining 10 letters, I have got A, 1 A, 2 I's and 2 N's. So I don't have to worry about this now. So you just have to worry about this. So these are the total number of words that can be formed starting with letter A. So these number of words will appear in this dictionary before the first word starting with E. So how many are these? 10 factorial by 2 factorial into 2 factorial. This is that you need to calculate. So 1 0 into 10 into 9 into 8 into 7 factorial I know is 5040. So divided by 2 into 2, that is 4. So it will give you 2 here. This is 90, or what I am going to do is, this is 18 into 504. 504 into 18 I'll calculate. Then I'll place 2 zeros in the end. Right? So this will give you 72 90. I hope this is the answer. Okay, you may reconfirm the calculation yourself. I hope this is the correct answer, but I want you to calculate it yourself and then confirm that this is the answer. Okay, how many 6-digit numbers can be formed using these digits? How many are these? 1, 2, 3, 4, 5, 6. So we have got 6 digits including 0, and I need to form 6-digit numbers which are divisible by 10 and no digit is repeated. So if these numbers are divisible by 10, then one thing is sure, that at this units place I'll have 0. So this digit is fixed. This digit is fixed. Okay, so I just have to worry about these 5 remaining digits. And if you see, I've got 5 places to fill. I've got 5 digits here which are all distinct, and I don't have to worry about 0, because if there would have been 0 in this, then I had to exclude that case where 0 can arrive at this place. But now I don't have to worry. I just have to arrange these 5 digits in 5 places in a row in 5 factorial ways, right? Because no repetition is allowed, no digit is repeated. So this is how simple it is. I just have to fix 0 here. Now I have got 5 places to fill and 5 non-zero digits here, right? And 5 digits, 5 places, 5 factorial arrangements, which is 120. This is the answer. The English alphabet has 5 vowels and 21 consonants. Okay. How many words with 2 different vowels and 2 different consonants can be formed from the alphabet? So I have to choose 2 vowels and 2 different consonants. So 2 different consonants I can choose. How many words can be formed? So once I have chosen these 4 letters, I can arrange them in 4 factorial ways. So these many words can be formed as per the given conditions. So how many are these? This is 5 into 4 by 2 into 1, so that is 10. This is 21 into 20 by 2 into 1, so 210. And this is 24, right? So there are these 2 zeros. 24 into 21 is that you need to find out. Then I'll place 2 zeros in the end. What is 21? 24 into 21. 24 into 20 is 480. 24 into 1 is 24. So this is 405. So these many words can be formed as per this question. In an examination, a question paper consists of 12 questions divided into 2 parts, part 1 and part 2, containing 5 and 7 questions respectively. So total 12 questions are there. In part 1 you have got 5, in part 2 you have got 7, and total there are 12 questions. A student is required to attempt 8 questions in all, selecting at least 3 from each part. In how many ways can the student select the question? So you have to attempt only 8 questions, and 3 have to be selected, at least 3 have to be selected from each part. So what can be the cases? I can select 3 from the part 1, then I have to select 5 from the part 2. 3 from part 1, can I write it like this? 3 from part 1, or let me write it as P1, okay? So I'll say 3P1 and 5P2, or 4P1, 4P2, because I have to attempt 8 questions in total, right? And in part 1 I have got total 5. So there can be another case where I can have 5 questions from part 1 and 3 questions from part 2. These are the only possible scenarios. So I have considered all of these. Now I'll calculate these separately and add these results, right? In how many ways can a student select the questions? So this is a question of selection. After I add these, I don't have to uh, calculate the arrangements. I just have to calculate the selections. So what is this? 3 from part 1. This is not 3p1. This is not, p doesn't stand for permutations. So you avoid this notation that I have taken, right? To avoid getting confused. So 3 questions from part 1 can be taken as 5c3, right? 5c3. And 5 questions from part 2 can be taken as 7c5. Or 4 questions from part 1, 5c4, 4 from part 2, 7c4, or 5 from part 1, that is 5c5, into 3 from part 2, that is 7c3. So 3 from part 2, 4 from part 2, 5 from part 2. Okay. So this is how much? 5c3 is 10. Let me change the color. 5c3 is 10, 7c5 is 21, plus 5c4 is 5, 7c4 is 7 into 6 into 5 by 3 into 2 into 1. So it is 35. I hope the calculation is correct. You need to confirm it yourself also. 5c5 is 1. 7c3 I think we have already calculated, which is 7c4, that is 35. If this is correct, then this is also correct. Okay, so this is 210, this is 150 and 25, that is 175, this is 35. So this and this is 180, 210, 210, so 420. Is there anything left? No, all the possible scenarios are considered and all these calculations have been taken. So 420 ways this student can select the questions, okay, as per the given conditions in the question. Let me select the color now. Okay. Determine a number of 5 card combinations out of a deck of 52 cards if each selection of 5 cards has exactly 1 king. So how many kings are there in total? There are 4 kings and 48 other cards, right, where there is no king, right? So 4 kings I have separated and there are 48 other cards in this deck of 52 cards. So I need 5 card combinations and each selection of 5 cards should have exactly 1 king. So to select exactly 1 king, I have to select it from here. So 4c1. These are the ways I can select 1 king. Exactly 1 king, right? Into. Now I need total selection of 5 cards. So I have to choose 4 remaining cards from these 48 cards in 48 C4 ways, right? And this is what I have to do. I have to choose these cards, right? I don't have to arrange them in a row or anything. So this is what I have to do. 4 into, this is 48 into 47 into 46 into 45 by 4 into 3 into 2 into 1. So this is anyways 24, so this will give you 2 here. So this is 8 into 45, I am doing separately. 8 into 45 will give you 360, right? Plus 47 into 46. This you can calculate separately. How can we calculate it easily? Okay, you can directly multiply it. Let me calculate. So it will be 42, 4, 282, 2, 188. So I'll have 2, 6, 11, 2162, right? And then I'll add 360. So 2 and 2, 5, 2, right? Excuse me. It is required to seat 5 men and 4 women in a row so that women occupy the even places. So total places are 9, right? Total 9 places are there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Out of these 9 places, so this is first place, this is second place, this is third, fourth, 5, 5th, 6th, 7th, 8th, 9th. So out of these 9 places, I will have 4 places that are even numbered, right? Because there are 9 places and I am starting with first place, then first, second, third, right? Like that. So these will be the 4 even numbered places and I want these women to occupy the even places. So 4 even places are there, 4 women are there. They can occupy the even places in 4 factorial ways, right? So the women are seated now in 4 factorial ways. And then 5 places are remaining and 5 men are there. So these 5 places can be occupied by these 5 men in 5 factorial ways. This is the answer, which is 24 into 120, right? Which can be calculated as 48, 28, so 2880, right? So these many ways, these many arrangements are possible. From a class of 25 students, 10 are to be chosen for an excursion party. There are 3 students who decide that either all of them will join or none of them will join. So there are 2 cases, right? Either all of them will join, either all 3 of them will join, or none of them will join. In how many ways can the excursion party be chosen? So there are 2 cases. Either all of these 3 will join. When all of these 3 join, right, I have to choose only 10 students in total. If all of these 3 join, I have to choose only 7 remaining students, right? These 3 are joining, so I have to choose remaining 7 for the excursion party out of the remaining 22, right? So there are total 25. I have to choose 10 from it. So if these 3 go, then I don't have to choose these 3, right? So let us separate these 3 from these 25. I have got 22 students to choose from and I have to choose 7 students out of these because these 3 are already chosen now. If none of them goes, right? If none of them goes, I have still 22 students to choose from and there is or here. So I'll add. I have 22 students to choose from and I have to choose all 10 students from these 22 because these 3 are not going. None of them is going. So I have to choose all of these 10 from the 22 students. So this is going to be your answer. What is your answer? 22C7 plus 22C10, right? Okay. In how many ways can the letters of the word assassination be arranged so that all S are together? So how many are these? 1, 2, 3, 4. So I'll tie them together and treat them as one unit. What else? 1, 2, 3. I've got 3 A's. 1, 2, 2 I's and N, T, O, N. So 2 N's and T, 1 T and 1 O. So how many are these? 3 to 5 to 7, 8, 9 and 4, 13. So let us calculate, let us count if we have left anything or not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I have considered all of these. Okay, so now I have tied these together because I need to choose the arrangements where all S are together. So I'll consider them as one unit, right? And apart from this, so how many were these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So apart from these 4, I have got 9 letters, which are these, right? Okay. So 9 letters are there. I am considering this as one unit. So total 10 units I am considering. So I can arrange them in 10 factorial ways, divided by 3 A's are alike, so I'll divide it by 3 factorial. 2 I's are alike, so I'll divide it by 2 factorial. For 2 N's, I'll divide it by 2 factorial. If somebody says I have to divide it by 4 factorial, no, because I'm considering this as one unit, right? So that is why the total units are 10. Otherwise, I had got 13 letters here. So I am considering this as one unit. So there are total 10 units which can be arranged in 10 factorial by 3 factorial into 2 factorial into 2 factorial. 3 factorial because of this, 3 A's, 2 because of this, 2 factorial because of this, right? So these many arrangements will be there where all S are together. Now their internal arrangements, these 4S can be written in only one way. So I don't have to multiply this with anything. This is your final answer. This is your final answer. Okay. So whatever this answer comes out to be, this is your final answer. You can calculate it yourself. Okay, so this exercise is over. This was miscellaneous exercise of permutations and combinations. I hope you would have enjoyed it. Thank you.